processing and its applications in its future. First of all, what is image processing? Image processing is the technique of applying certain algorithms to digital images to enhance their quality and to extract meaningful information or to convert them into a different format for viewing or analysis. Also, it treats an image as a two-dimensional signal utilizing methods like noise reduction, contrast adjustment, and pattern detection to transform raw image data into a clearer or more useful form. Therefore, here, in the case of image processing, we can transform the raw image into a clearer form, or depending upon the applications, we can change it. And first of all, we are going to see what is an image. Actually, an image may be defined as a two-dimensional function f of x comma y, where x and y are spatial coordinates, and the amplitude of f at any pair of coordinates is called the intensity or gray level of the image at that point. And there are different images available. There are various types. First one is binary images. Second one is grayscale images. And the third one is color images. In the case of binary images, it contains only 2 pixel values, typically black as well as white. And this is used for the task like optical character recognition and object identification. And the next one is grayscale images. These grayscale images represent the intensity or brightness level through various shades of gray from black to white. It's used in medical imaging and satellite imaging. Next, color images. These color images display color values using different color models, and mostly commonly used model is RGB model, that is red, green, blue, and which use multiple color channels to represent the image. And next, we see about digital images. What is a digital image? A digital image is nothing but an image which is having the amplitude values of f. Already I said f of x comma y. In that, the amplitude values of f of x comma y are finite as well as discrete quantities. If it is having this kind of classification, then we call that as a digital image. Therefore, a digital image is composed of a finite number of elements, and each of which has a particular location as well as its value. These elements are referred to as picture elements, image elements, or pixels. When you see this diagram, you could see the pixel values, and here have taken the x-axis here and the y-axis here. Here, this point 1, 1, the square, which is representing a pixel at a point 1, 1, and it's having the intensity level of 255. And next, when you see the x-axis 5th location as well as the y-axis 2nd location, this is also 5, 2. This is also considered as a pixel. In this way, you can say the pixel. Therefore, pixel is nothing but a picture element. Actually, for a single pixel, the range of its color value is often 0 to 255 for each color channel in a typical 8-bit image. Next, we are going to see what is the need of going for processing of an image. What is the need of going for processing of an image, and why do we need to go for process images? First one, to facilitate picture storage and transmission. And the next one, to enhance and restore the images. And the third one, to extract the information from images. And the fourth one, to prepare for display or printing, that is depending upon the applications. Next, we shall see the different stages of digital image processing, and this is the diagram which shows the different stages in digital image processing. Initially, it is consisting of the first stage as image acquisition. In this stage, the image can be acquired from the device which is known as camera or scanner and converting that into a digital format. After acquiring the images, we have the next stage, that is called image filtering and enhancement. In the case of image filtering and enhancement, you are going to manipulate the image to make it more suitable for a specific application. Whatever may be the applications, according to the applications, we can make it more suitable by improving its visual appearance, such as sharpening of the image or brightening of the image. And the output of this phase, that is image filtering and enhancement, this is given to the next stage, that is called image restoration. In the case of image restoration, so we are going to remove or correct certain distortion if it could find, and if you have any degradation that may have occurred during the image capture or processing, such as blur or noise. Because depending upon the applications, if you are not performing image restoration, you are not at all getting in a good efficiency. Therefore, so you have to restore the image, and it plays vital role in the stage of digital image processing. After this image restoration, we are going for the next as color image processing. Actually, color image processing specifically addresses the color aspects of an image, managing and enhancing color representations for various applications. After this color image processing, we have wavelets and multi-resolution processing. In this technique, you are breaking down an image into different resolution levels to facilitate analysis and processing. After this, so you are going for the next stage, that is image compression. Actually, image compression reduces the size of the image file to enable efficient storage and transmission. During the transmission, if the size will be big, it will not satisfy certain constraints. Therefore, the particular image will be compressed without any significant loss of important information. And this is for the enabling of efficient storage. After this image compression, we are going for morphological processing. This morphological processing involves the use of techniques to analyze and refine the structure and shape of the object within an image. Next, image segmentation. Here, in this phase, the image is partitioned or splitted into multiple meaningful segments or objects, so that it is easier to analyze the individual components. And the next one is representation and description. After segmentation, the results are converted into a form. The results which you are getting from this previous stage is converted into a form that is suitable for computer processing and further analysis. After this, you are giving that to the object recognition stage, and this is the final stage that the system identifies and assigns labels or categories to the objects that have been detected in the image. These are the different stages of digital image processing, and we can divide the area from image processing to computer vision into 3 levels, namely low level, medium level and high level. In the case of low level processing, the input is an image. Also, the output is also an image. For example, you can say denoising, image sharpening, contrast enhancement. And next, we come for medium level processing. The input is image and the output is features. And examples include object recognition and segmentation. And next, high level processing. In the case of high level image processing, the input is features and you are getting recognized outputs. For example, screen recognition, automatic navigation, etc. And next, different techniques followed in digital image processing. The first one is spatial domain techniques. In the case of spatial domain techniques, operations are performed directly on the pixels. And the next one is frequency domain techniques. In the case of frequency domain techniques, processing is done in the frequency domain of the image, often using Fourier transforms. Next one is morphological processing. This morphological processing uses some mathematical operations and based on shapes within an image to perform certain tasks like image segmentation. The next technique is wavelet transform. Actually, wavelet transform is a technique for analyzing images at different scales and resolutions. Next technique is image enhancement. When you are applying image enhancement, it improves the quality of an image for visual interpretation. Therefore, it plays a vital role. And the next one is image restoration. It aims to remove certain noise or blur from an image. And next one is image segmentation, and it divides an image into multiple segments. Next one is image compression, and this reduces the storage space required for an image. Next, we are going to see certain applications of image processing. The first one is image restoration. The first image when you could see a damaged image, and the second image you could see a restored image. Therefore, in the case of image restoration, you are removing distortions as well as degradation that have been occurred. And the next one is image colorization. And here, when you see the first image, actually this is original black and white image. The same image is changed as a color image. That is, it's coming under image colorization. And the next one is image enhancement. In the case of image enhancement, here you have improved the visual appearance. When you see this picture, the first one shows the original images, and the second one shows the enhanced images. Comparing the original image as well as enhanced image, there is an improved visual appearance that is given by the use of image processing techniques. The next one is face detection. In the case of face detection, you are identifying and locating the human faces within digital images, or maybe from videos by analyzing the pixel patterns and recognizing the characteristic facial features like eyes, nose and mouth. And here when you see this picture, you could see a lot of faces are detected. This is also application of this image processing. Next one is face tracking. Actually, the face tracking, so you are going to detect and follow a specific face across multiple frames in a video sequence. From the video sequence, so you are going to find a specific face from multiple frames. That's a kind of face tracking. Next, face morphing. This face morphing synthesizes a new intermediate face by blending two or more existing facial images. You could see in the second picture, you could see the images have been blended so that you can synthesize a new image. And next, the personal identification can be done by the use of iris recognition, and this uses the image processing techniques to capture, pre-process, segment, normalize and encode the unique patterns of an iris into a digital code for identification. When you see about the impactful application of image processing, you can see image processing applications in healthcare. In healthcare, there is a tremendous image processing applications available, and the image processing healthcare applies computer algorithms to medical images from sources like CT and MRI scans to enhance the quality, to identify anomalies and to extract diagnostic information for diagnosis, treatment planning and surgical guidance. Key applications of this include detecting early signs of diseases like cancer and aiding in surgery. And next you could find the applications, the case of automotive and robotics. Computer vision, which is powered by image processing, enables autonomous vehicles and robots to perceive the environment, to detect obstacles and to navigate it efficiently. Image processing in automotive and robotic transforms digital visual data into actionable information, enabling tasks like self-driving, autonomous navigation, quality control and assembly. Next, another one tremendous application using image processing is in industry automation. Image processing with AI is improving manufacturing process through automated inspections, anomaly detection and overall productivity gains. And here, this uses cameras and algorithms to analyze the visual data, enabling automated quality control, defect detection, product inspection and robotic assembly. Also, it enhances the efficiency and accuracy in manufacturing by enabling systems to monitor products at high speeds and to identify if there is any flaws. And next, we could find a tremendous application in space. Digital image processing plays a crucial role in analyzing images from space, supporting advancements in this vital field. Image processing in space research transforms raw telescope data into clear, scientifically useful images by correcting noise, enhancing features and combining data from multiple instruments or wavelengths. Also, it transforms raw sensor data from spacecraft and telescopes into scientifically useful and visually appealing images by applying algorithms to enhance clarity, highlight specific features and to enable autonomous navigation. Next, the future of image processing. The future of image processing leads with AI integration, software defined image processing, VR as well as AR enhancement. In the case of AI integration, deep learning and AI improve with AI improving accuracy as well as to improve the process speed. In the case of software-defined image processing, it offers more flexibility and control over the entire image pipeline, moving beyond traditional hardware-centric methods. In the case of next one, development of virtual and augmented reality with the use of image processing techniques, it improves the quality. As a final, digital image processing is an on-demand technique and plays a crucial role in this evolving era. Digital image processing is the process that involves analyzing and manipulating images digitally by a computer to make them more informative for human interpretation and picture information for tasks such as maintaining storage, fast transmission and extraction of pictorial data. And these are the main thing we have